Hi! If you're not familiar with this electric escape project, here's a struts don't work. Here's a playlist. In the last installment, we installed motor mounts. Well, I installed motor mounts. You just watched. The next big thing to do is install the batteries. But I can't do that because I've ordered them, but they haven't arrived yet. So this episode, odds and ends. Mostly power steering. Power steering. The Escape has a hydraulic power steering rack that I intend to keep and utilize. However, there's no longer an engine in there to drive a belt that drives a hydraulic pump that's mounted on the side of the engine. So I'm going to be replacing it with this, the electric power steering pump from a Volvo S40. All right, let's see if it turns on. Once I connect this signal wire, after a few seconds, it should come on and dump all of the remaining contents of its oil onto the floor. It works. All right, I put a clamp on it. Let's try that again. And maybe it won't launch itself off the bench this time. Yeah! Oh, that's real quiet. Okay. This is the rubber isolating mount bracket that came with that pump. I need to figure out how to mount this into the car, and therefore mount this into the car. No. The holes need to be spaced just a little bit further apart. And to finish welding this up, it's a good excuse to practice TIG, because I'm currently terrible at it. That was awful. Yeah, not getting much better right now. I feel like I'm getting worse, if anything. I'm getting worse. I feel like I'm too shaky for this. All right, well, you may call this giving up. I'm going to call it practice on parts that don't matter. Welcome back to my kitchen from the 70s. Here's 48 chicken eggs, 3 goose eggs, and a throttle pedal from a Prius. This video is brought to you by Factor, delicious ready-to-heat meals delivered straight to your door. And don't you dare skip this ad, you're going to like Factor. Since I've started working with Factor, both my parents and my grandma have become Factor customers, and they absolutely love these meals. Just open the package, vent the film with needless aggression, pop it in the nucleator for 2 minutes, and just like that, you've got a delicious meal ready to eat and prepared in half the time it would take you to prepare something that takes twice as long. There's so many reasons to try Factor. It's easy, it's convenient, you don't have to worry about portion control, make less trips to the grocery store, make fewer trips to get takeout, and the quality. These meals are so good. That's what continually amazes me. And they're different every single time I get Factor meals. If you want to try out Factor yourself, go to factor75.com or head to the link in the description below this video and use code AGINGWHEELS50 at checkout for 50% off your first box. You won't regret it, I promise. This is jalapeno cheddar lime chicken, and I'm sure it'll be amazing because they all are. And there's also calorie smart and vegetarian options and some other options if you prefer that. Oh, that's spicy. Oh, it's almost like I ate a whole jalapeno slice. Now I need to mount from here to here and from here to here. In theory, this 1/8" piece is way too thick for my bending brake. And in practice, too. This piece is going to go here to brace this mounting hole, and this means I did one of two things. Either I bent this the wrong way or drilled this hole on the wrong side. Either way, I screwed up. It's looking good so far. If I had to do it over again, I'd move it back that way a couple inches, but I don't think it'll cause any problems. The battery box has to go here, and that's the main clearance thing that I'm worried about. Now I have this one last mount left to brace. Oh yeah, that looks kind of garbage, but that's okay. It fits, and it's super rigid. If you're thinking, that looks wiggly, it's because I haven't bolted it down there, but the bracket itself is super rigid. Now to take this out and paint it black. Now this needs to go back in only long enough for me to see how long the hydraulic hoses need to be. 16 inches. Okay, come back out now. And to remove the hydraulic hoses, that's the supply line, the pressurized line, the non-pressurized return line. I don't know how this comes out of here, and I'm afraid to break something. No, I'm getting it. I think really dry O-ring. The reason I chose this Volvo power steering pump was actually a recommendation from Jared from the Questionable Garage because it's really easy to wire up. There's 3 wires that go into it, aside from the 2 main power wires. There's CAN high, CAN low, and then the switch power supply. But if you don't provide any input to the CAN wires, it just defaults to working. So I don't need to mess with these, and it'll just be on. But as an added bonus, and something I didn't think about, this is a Volvo part from the early 2000s, meaning it's also a Ford part. So the supply line here and the return line here are the same size fitting as what I just took out of the Escape. So no adapters will be involved. I'll just have to have a hose for the return line, and I'll have to have a hydraulic hose made up and crimped into place for the supply line. Super simple. Here's the new power steering line I had made up, and well, I didn't expect it to be braced. It's not wrong, it's just not what I expected. I expected them to take this fitting here and crimp it directly onto the end, but you know, whatever, it works. Here's the return line, which doesn't have any support over here anymore. I might want to do something about that. There we go, that should do it. I'll provide support there and keep it from being bent off. Now here's the high pressure supply line with the new hose fitted. All right, now the high pressure line fits right here with minimal bending. And the return line goes right here. Now, these need to be tightened. All right, 2 steps left, which are wiring it up and mounting the remote reservoir. Silly French word. This is the remote reservoir mount, and how did this mount in the car? Because instead of holes, it just has these 2 dimples up here. Did it have some sort of mount that it clamped into? I don't understand how this would be held in place. Now for a riv nut, or 2. I had a task to do in here that I was absolutely dreading, so I took that as a sign that I should go ahead and get it done. So it took a couple hours last night to hunt through this fuse box that's now mostly redundant for a 12-volt source that's only on when the ignition's on. And I found it. These 2 relays here are what used to be for the ECU and the fuel pump, and the output of those is only on when the ignition's on. So I found one of the wires that comes out of them down here, and in the future I can use this for my 12-volt switched input for the VCU and a bunch of other stuff, but for right now, I just have it temporarily wired up to the switched input on my power steering pump so I can test it. All right, you're going to be hearing a bunch of other sounds, but hopefully you can hear the power steering pump through the other beepings and whatnots. I'm going to put it in the accessory position so I can get a feel of what the steering feels like without the pump on. And it's going to require some bleeding, but let's turn on ignition. Can you hear it? A little hydraulic pump going, all right. Oh, it works. Let's move it back and forth to bleed the air out of it. I have power steering, listen to that. Power steering! All right, let's turn it back on off again. Oh yeah, much heavier. That is doing its job. Now, as I mentioned earlier, I went with electro-hydraulic power steering because it's much easier to install, but also I wanted to hear this fun sound in the engine bay. I thought it would sound like a hamster on a wheel or something moving around in the engine bay. If you wanted it completely silent, you could go with fully electric power steering, which is an assist motor on the steering column, but that's a lot more work to install, and you don't get this fun whirring sound. On top of being a lot quieter, fully electric power steering is going to be a lot more efficient than my electro-hydraulic setup I've got going on here, because the motor driving this pump is going to be running basically all the time. If I had fully electric power steering, the assist motor would only be drawing any power when it's providing assistance. In other words, when the wheel is being turned, which is not most of the time. Something to consider if you're considering an EV conversion for yourself. With the power steering tackled, say for some finishing touches on the wiring, the next step was supposed to be tackling the power brakes, which is just adding a vacuum pump, an electric vacuum pump, to the existing brake booster. But I'm going to have to wait on that. I ordered a vacuum pump kit from EV West, which is just the pump, a pressure switch to turn off the vacuum pump, which once the vacuum is built up, some hoses and fuses and relays and stuff. But that kit is currently on back order, so I'll have to wait about a month for that to come back into stock before I can tackle that. The vacuum pump for the brake booster is another thing that's going to be generating noise in my no longer in engine bay. If you wanted a silent alternative to that, you could use an eye booster. Instead of having a big vacuum diaphragm to assist on your braking, it's got sort of an electrically assisted screw setup. It's what Teslas and a bunch of other vehicles used, and it's dead silent. But again, that's more work to install, so I'm going to go the cheap, easy route. This box contains new brake parts, rotors, drums, pads, shoes, but it doesn't make any sense for me to install these right now because the shop that's making my new custom CV axles, they told me that the outer spline pattern on the rear axles was a little bit of an oddball pattern, so it's easier for them to make new custom hubs with their own spline pattern on the inside. So if I were to install these today, I'd have to take all these parts back off again when I go to install the new custom hubs in the future. So I'm just going to leave it for now. And no, I'm not going to be upgrading the brakes. I'm going to be running stock brakes just with new hardware. And if you're thinking, you're going to give it 900 horsepower but stock brakes? Yes, I want you to remember two things. One, I'm not going to be tracking this. And two, regen braking. Speaking of wheel hubs, this wheel bearing is shot. Never noticed that before. Doesn't matter, because like I just said, I'm going to have to replace all of the wheel hubs anyway, but perhaps a bit violent. Oh, I never plugged the fog lights back in. Okay. I'm going to show you something in here that has been absolutely baffling me since I took the engine out. This vertical strut here, it bolts up to the top and it's part of the hood latch assembly, and it's supposed to bolt down to this bottom rail down here, but it doesn't reach the bottom rail because the fans are in the way. I don't understand how this ever worked. Initially, I planned to reuse this radiator, but I've changed my mind for two reasons. One, this radiator is not in the best shape, and it's full of copper flakes from stop leak, which is less than ideal. But most importantly, and that's something I didn't know when starting this project, is the motors and the batteries operate at very different temperatures. The max operating temperature for the drive units is, if I can remember correctly, 180 degrees Fahrenheit. If the batteries got to that temperature, they wouldn't be batteries anymore, or at least they'd be much worse at their job. So I don't know if this was 100% necessary, but I'm going to isolate the two cooling systems, which means two radiators, or heat exchangers, really. I don't know if I'm going to have them stacked. I'm going to have to look up radiators. I haven't done any research yet. I just needed to get this one out to see how big it was. I don't know if it's going to be two of them stacked in front of each other or on top of each other. Back on the Escape, I have bad news. This piece still doesn't line up with anything. Now it touches the bottom frame rail, but the screw hole's off by a good centimeter. Some part of this is bent, but I don't know what yet, and it's really bothering me. I fixed it. That gentle curve that looked like it was supposed to be there, apparently it wasn't. I bent it the other way, and now it fits. I figured out what to do about my radiator situation. I've ordered another radiator exactly like this one, presumably with less stop leak. For the second radiator, for the second half of the cooling system, I don't know if it'll be for the batteries or the motors, I've ordered 4 heater cores. Here's my new radiator, and it arrived pre-bent in all sorts of directions. And here's my 4 heater cores. Now, why 4 heater cores? Well, 4, because that's exactly the number of heater cores that I can fit on the face of this radiator. And heater cores, because A, they're cheap. These were only $17 a piece, and B, heater cores are just radiators. These are actually twice as thick as this radiator, so the 4 of these plumbed together in series will make up just as much cooling capacity as the radiator they're strapped to the face of. And because I'm going with heater cores strapped to the face of this other radiator, I don't have to worry about fabricating a mount for a second radiator. It's all just easy and cheap. That's why I went with this solution. Now I need to strap these to the face of this and then get all of this into the car. They'll be plumbed up something like this, but this metal-on-metal contact is no good. So I've bought this neoprene flooring. Let's take this to the laser. Now that these rubber strips are glued to the back of these, no more metal-to-metal contact, it's nicely rubber isolated. Now to attach the heater cores to this big radiator, I'm just going to use these bits of threaded rod that go through both cores. On one end, it'll have a nut that I've welded in place, essentially making it a long bolt, and then on the other end, I'll have a nylock nut to keep it from unraveling. And to distribute the load, I'm going to be using these stainless steel washers, but metal-to-metal contact, again, is not my friend, especially on delicate heater cores like this. So I went on a hunt for nylon washers and didn't find any. Instead, I went to the store, bought this plastic bin, attacked it with the laser, and made my own washers. Little side note, this is polypropylene. Cuts like absolute crap and makes a terrible acrid smell on the laser, but I have my washers. If this was a cooling system for an engine, it would get too hot in there and these would melt, but it's not, so they won't. This is where they're going to be situated. Finding this S-piece helped a lot. Now to mount them in place, I'm going to stab through the fins with my stabbing tool here. Then I can sort of stake it in place with these sections of filler wire. Now I can take the bolts I just made, stack on a metal washer, followed by a plastic washer. Then go through and replace all these pieces of filler wire with a bolt. Then again on the other side, I can follow it up with plastic washer, metal washer, and then a nylon lock nut. Then do that for all the rest of them. Done! Now I need to get the old radiator fan assembly off of the old radiator and put it on the new one. I might end up replacing these at some point because they're on-off switches. They're not speed adjustable. These 2 holes down here are for the rubber mounts the radiator sits into, but those rubber pieces were missing. So I modeled them up in Fusion 360 and printed them out of TPU. If this were an engine bay, it would be way too hot for TPU and it would melt, but it's not, so they won't. In goes the Franken radiator, slotting into the TPU mounts nicely. And now it's ready for me to do whatever's next I need to do with the cooling system in the future. Before you go, I have a few questions for the members of my audience that know more than me, of which there are many. This high voltage disconnect on the top of the front power distribution box on the Coda. I assume this can handle 350, maybe 500 amps. Is there a connector similar to this for high voltage that can handle 2,000 amps? If not, is there a connector that can handle 1,000 amps that I can double up on? The reason I ask is because my next project is the battery boxes, and it would be so much more convenient if a connector, a watertight high voltage connector existed that could handle my power requirements rather than me having to make something myself. And that's it for now. Tackled 2 smaller items in this episode. Next time, it's back to bigger stuff. The next step is battery boxes, and they're going to be a real big accomplishment. I'll need to build 4 or 5 of them, depending on how many battery modules I can shove into the engine bay. Hopefully it's only 4, and they're going to be more than just containment devices for the batteries. They'll have, obviously, integrated mounts. They'll be made of aluminum. They'll have integrated high and low voltage connections, as well as integrated cooling. There's going to be a lot to them, so I'm going to start as early as possible. But that is the next episode. As always, thank you for watching. I'll see you next time.